It's genuinely hard to truly screw up a furnace install.
Mm-hmm.
It's really easy to screw up a heat pump install. The furnace is there to back you up. You're going to get bit much less often. And then if you have any way to watch runtime, you'll see that the heat pump side of the hybrid carries a shocking amount of the load.
Oh, yeah. I'd say my furnace is going to run about 10% of the time. Some of the people are like freaking out. They're so hardcore electrification. They're just like, we got to get rid of fossil fuels by 2026. When we got to stop burning. That's like, the market's not ready for it. And I would say a 90% reduction in gas heating is such a powerful win. If everybody just went to hybrid systems, the win is so big for the electrical industry. And I don't know why people haven't readjusted. I drive a hybrid car.
It's a personality type thing. Yeah. And that's where I came from a little while ago. But electrification is not a technical problem. If you learn how to size using past energy use, you can size really closely. Like far closer than manual J, which drives me bonkers. Although I just heard at the symposium, they're planning on adjusting the formulas. So hopefully it'll be closer. Because right now, manual J is really consistently double actual heat load.
Mm-hmm. I used a conduit and did a LiDAR.
Yeah. And I'm using Ampli and getting closer, but I'm still 25 to 40% high.
Yeah.
But I'm not there.
Mine wasn't that high because I've been watching my runtime where my heat pump, it seems to be pretty spot on. But anyway, I also made sure I got rid of that southern wall. I just think I get people being hardcore on it, but I also, my gosh, just think of the reality. If we were just to do that one thing and get everybody, even if they only used them down to 30 degrees out, so heat pumps down even to 30 degrees.
You know that I helped with the paper on this, right? Because I proposed, it was funny how Twitter can be powerful. I did a thread on how we should change every air conditioner to a heat pump because it's not that much in the way of parts. It's like $100, $150 in parts, and everybody already makes them. So it's not like it's a major line change. It's just running more of one product than the other. But in the paper that came out of that thread, we did a 41 degree balance point, which is super conservative for a couple of reasons. One is basically every heat pump is above a 3 COP, above 40. So it makes the consumption numbers look best. But also, have you really seen a house where a heat pump can't carry it down to 40?
No.
Some pretty bad houses.
And I probably would size for, like in northern climates, I would size the heat pump for the cooling and then rely on the gas furnace for the heating. And that way it really would be easy to do it down to 40 degrees, even with
even with that little bit, that was a 39% reduction nationwide in natural gas use.
I'd say that's a win.
That's a big win. And we've both seen, when you're seeing like a 90% reduction, I was usually seeing 80 to 90% gas usage reduction on the hybrids that I did.
The other thing is,
a huge move.
Is for me, I moved into a new place and I got gas logs. I got a gas dryer. I got a gas stove. I've got a gas hot water tank. I've got a gas heater in the garage. And I'm not going to switch over all that infrastructure just to put a heat pump to do a complete electrification. It would have been crazy expensive.
Yeah.
My primary gas usage is the gas furnace. And so just eliminating that one little appliance and going over to the heat pump, it provides a ton of comfort and a ton of energy savings. I don't care what side of the aisle you're on. You should care about managing the resources we have. It's not about just what's the cheapest energy we got.
What do we make here too?
Yeah.
We do drill for our own oil, but in my understanding, it's a much lighter crude than what we can actually process. So we actually put that on ships and send it around the world to get refined. And then we bring in other oil and bring it in here to refine. I
was reading an article just on that the other day too, where they were talking about how many ships we would stop going across seas if the whole world electrified, because it's the amount of ships. It's crazy amount of shipping that goes to just moving oil and gas.
Yeah, that's where the renewables can be wonderful. Like just totally apolitically, Texas is a really good grid to watch. And despite their challenges a couple of years ago when everything broke because they went way out of spec on everything, that was Valentine's Day, 3 or 4 years ago. But like this summer, if they had last year's grid, it would have broken with some of the hot spells they had. But they added an ungodly amount of solar. And that solar actually saved them in July and August because it was generating enough that despite a much higher peak, they rode it through. And I mean, that solar is going on the grid, not for green reasons, not tree hugging green reasons. It's going on for money loving
Yeah.
green reasons. It happens to be the most economical way to generate power.
Yeah. I think nuclear is still my favorite.
You got to do your math, man. It's 3 to 4 times as much. It's 15 or 20 cents a kilowatt hour generally to generate, where solar is 1 to 6, depending on how you do it. Residential's more. But
Yeah.
I still like nukes. So don't get me wrong. I like nukes, but they're really expensive and we suck at building them. The only countries that have built them halfway decently are China and Saudi Arabia, but they don't really have like any environmental regulations and they can basically use slave labor.
Yeah, we've regulated ourselves out of a lot of great technology. Sure.
Yes.
So
yeah, that part's challenging.
Yeah.
But I'm with you. Nuclear will remain a piece of the puzzle, but I really wish that we could make it cheaper. Wind and solar paired with batteries are going to be a huge chunk of moving forward, and we can make all of that here. Like solar panels we haven't made here, but that's actually one of the good things that came out of the IRA. A whole lot of manufacturing plants are going up to make the stuff we need to make power here.
Yeah, that'll be interesting.
Make all the minerals and so forth as well.
All right. We are 40 minutes into a podcast, so we probably should wrap it all up.
We bounced all over the place, Jimmy.
Yeah, that's all right. It was interesting.
Hopefully people will enjoy it a little bit. Open your mind to hybrids, right?
All right. Very good.
Ben's hopping in now. And install pieces we didn't talk about a whole lot, which goes back to measure quick, which I'd love to touch on. In the hybrid debate, one key thing I want to touch on, and I think we'll agree on this. There's plenty of stuff we don't, but I think this one we will. If you know the phrase that slow is smooth and smooth is fast, that applies here. Mm-hmm. So it may look slow to move to hybrids if you're looking to electrify, but on the low ends, like I saw a nice little study out of Toronto. They had a 3,000 square foot house built in the 60s, so leaky as a sieve, and they put a basic single stage heat pump in it. They got a 55% reduction in gas use out of that house. That's really significant with a mediocre piece of equipment in a cold climate in an old leaky large house. That's basically worst case.
I think the trick there is getting a huge gas reduction without a huge electrical increase.
Yes.
So when you're using the heat pump during that warmer time of year,
COPs are high.
The COPs are high. You're not losing comfort, and you're using the electricity the most efficiently you're going to ever use it. So that's where people get bent when they go with full electrification, is when all of a sudden they're expecting to save money, and it costs them a lot more.
That can be painful. I haven't had it happen, thankfully, although a lot of it is people don't realize, I don't have a gas bill anymore, so I need to figure out what my gas bill was and add it to it. And then oftentimes it's not that far off. But like your friend in Minnesota with shutting his heat pump off, yeah, that's going to really hurt you.
And that's the kind of stuff that we're running across. And
a hybrid avoids that.
A hybrid avoids that completely.
And a couple of other key points on it. Hybrids are very emergency change-out friendly. Mm-hmm. As long as there's a heat pump on the shelf, which can be a problem. But you don't have to size the equipment. You can do but change the AC to a heat pump, and it'll probably work okay. As long as your static's not crazy. So that's a whole nother thing.
Yeah, the Energy Conservatory, that static, the airflow screening they do. But it's gotten to the point now where almost your furnace, a lot of times, because the really low delta T's the furnaces are running, require more airflow than a heat pump or the air conditioner does.
Yeah, that's been wild.
It has. Yeah, because you're moving a lot more. Yeah, it does make sense. There's a lot more, we're moving a lot more air. And so you're saving on gas, but you're really losing on the electric side. So,
but what's that noise? So that awful screaming. Oh, that's just the air handler. Don't worry about it. Yeah. It'll die in another year or two. That brings us to some install practice questions. One is be aware of your static pressure. And that's also a nice place where if you downsize the system a size, you can come close to right sizing the duct system. But you touched on earlier, evacuation is critical. Mm-hmm. What dew point does 100 microns translate to? Because you told me that.
About -60, I believe, somewhere in that area, -50, -60 wet bulbs. So yeah, it's pretty darn dry. But here's the thing you got to remember is that like a filter dryer can remove moisture, but it's got a limitation. Yeah. And once it becomes fully saturated, a drop of moisture in, a drop of moisture out, it can't hold anymore. It's just like a sponge. So it can only hold so much, and that desiccant can eventually get overloaded. So keeping it like you have one on a lot of heat pumps, especially mini splits, you have one chance to do it right. If you don't do it right, it's going to shorten the life of the equipment. There's just no question it will shorten the life because it's a little chemical plant. Once that little chemical plant started, it's going to just continue on until it's at the end of its life.
Yeah.
So anything we can do to make the amount of moisture so minimal in the system that the remaining can be controlled by the dryer, just absorbed by the refrigerant, is going to be money spent. And if you use, I have a copy right here on my desk.
Sitting right there.
That book's written in 1959. In 1959, they're like, you should be pulling down, hitting 100 microns with a decay no more of 200 microns. That was for air conditioning, refrigeration, general stuff. Today, we're at like 500 and 1,000. And for a heat pump, that's not anywhere near low enough, especially for a cold climate heat pump, if you want any kind of longevity out of that piece of equipment. The other thing we relearned from review of vacuum for service engineers was like, hose conductance speed, how critical it is to use large diameter short hoses in a vacuum. Like you're using those True Blue hoses, those have a conductance speed of 56 microns for a 1 meter hose at 3/4 inch diameter versus a conductance speed of a typical manifold gauge is like 0.7 CFM, 0.7. So 56 CFM versus 0.7 CFM. So that's why like a True Blue hose is 90 times faster to evacuate down to 100 microns.
They're insanely fast. When we put this Bosch in here, I don't know, we ran it for 10 minutes and I forget exactly where we got down to. I think it was under 50. I want to say it was like 46.
And the key thing is once you hit that is you got to isolate it off and do a decay test because the decay test is where you identify how much moisture is there. Just because you hit a vacuum level doesn't mean it's dry. Drying out takes time. Now, the deeper you go, the faster it's going to dry out. There's no question about it. But you want to make sure that while you're pulling down, that you didn't, if there was any liquid in the system, you probably could have frozen, especially on a heat pump if you're installing it in the winter. People make bonehead mistakes. They go out and they put a heat pump in the winter. They take the line set outside and they have it sitting on the ground for 3 hours before they start roll it out and start running through the house. And you want to keep all that line set at room temperature as long as you can, and ideally feed it from the inside out so that that line set's never getting cold, because it's going to, as soon as you open it up and it's cold, it's going to start pulling in moisture in from the inside of the house because it's going to condense
like the air
crazy.
And condense on.
Yeah. Vapor pressure travels from high to low, so it's independent of air movement. So it doesn't take air movement you think about your bathroom. As soon as your mirror falls below the dew point temperature, the moisture magically, on that glass. And the same thing happens on your line set.
Outdoor humidity, I view it like the blob going through a window. Yeah, you don't need any airflow. All you need is a difference in humidity levels.
So making sure that you're keeping that line set warm, making sure that you are given enough time for your decay test to make sure it's good. So once you put that heat pump in, if I was putting one in the wintertime, the first thing I do is set the heat pump, get it hooked up to the 220 and power it up, and let the crankcase heaters and other components start to warm up the heat pump.
Refrigerant warm.
Yeah. Get the refrigerant warm out of the compressor oil, so that when you go to start the thing up, it's not going to be an issue for it. Because sometimes they want you to have 12 to 24 hours before you start it up.
That's what we did with the fits. That was in the install manuals for those.
Yeah. So let them warm up, and then I'll take if I'm doing an install in the wintertime, I'll kick my furnace on and run my furnace for 15 to 20 minutes while I'm doing my evacuation. And it just warms up the evaporator coil, warms up the line set, and it just helps drive that moisture out of the indoor coil in the system. Then I'll also take my torch, because my coldest place is outside. That's where my moisture is going to get to. I'll just take a torch, like a little propane torch, warm up the line set outside, just run some heat over it to get the moisture driven out of it. You can actually see in the vacuum gauge, as soon as you hit it, you'll watch that vacuum rise, and that's because you're boiling moisture out of the line set. Or you'll turn the furnace on, you'll see it rise. And it's usually moisture that's causing an increase in vapor pressure.
So deep vacuum's key. What about brazing with nitrogen or pressing?
Either one is good. I like a braze from the fact that a braze has pretty much a zero leak rate, and press is a very low leak rate. So it's not, I don't think a properly pressed system over its lifetime is going to need recharging again due to leakage of the press fittings, unless there's like a ridiculous number of fittings. But for the most part, the big advantage with press is you don't have to flow nitrogen, huge amount of time savings. But what I like to do is I'm still a big believer in bending tubing. So as much as I can bend, I'll bend and then minimize the number of press fittings. So if I only got 2 or 3 press fittings or 4 press fittings,
Oh,
that's
got it.
great.
So the refrigerant flow, I would imagine when you put it through a hard 90, it gets turbulent.
Yeah, it does. But all the refrigeration stuff has got wider turns, so it's not going
Okay.
to be an issue.
Just
Press or
curious.
non-press. The little bit of deformation that the press fitting makes is insignificant. They've tested that multiple times. If more manufacturers didn't put the bells on equipment, in other words, if you want to braze it in, you have to swedge it yourself. Otherwise, it's just a straight stub of three quarter and 3/8 copper out there.
Yeah.
I think the industry would naturally transition to press because it'd be a lot faster. But if I got to drag out my torches to sweat on a couple of stubs, then to do the 2 ends of the line set's not a big leap to go indoors and just move my torch indoors and do it because I got to get nitrogen out. So
You don't want to pull out all the tools. You want to pull out one set of the other.
And I got a buddy of mine, and what he does at the office is they have a torch set up, and then they just open up the side of the unit right there at the office, and they have one of their guys set up with a nitrogen tank and things, and they braze on the stub for the guy that's going out in the field, and the guy in the field presses everything on.
It'd
So
be good if we got longer stubs. Another couple inches would help.
yeah, that costs money, so let's forget that. But we are seeing some people come up with some creative ways around that issue. And so that's good. Hey, have you had a chance to try the AI bot and MeasureQuick yet?
No, I haven't. I have bought all of the tools now to use MeasureQuick, but like I'm running on 4 hours of sleep right now. But once I get all that done, like I'm going to move this unit myself here. Probably bring in my friend Bruce, who's helped with the installs, but he's gotten to a place health wise where basically he sits on a bucket and tells somebody what to do. Mm-hmm. So I asked him the other day, will you sit on a bucket and tell me what to do? I'm working on my 608 because we're going to create a bunch more Airbnbs in the next couple of years. So there's going to be a bunch of mini splits. I don't love mini splits, but for an Airbnb, they're the answer. You got a tiny little space. I'm not putting a duct system in a camper. Mm-hmm. I want to learn to do all this stuff, but I've got your 9 probes. I've got the TrueFlow grid, and I've got a couple of other manometers on top of that. So I'm collecting all the tools. Next up, True Blue hoses.
Yeah, those will be blue vac micron gauge, so you can actually do a proper decay test.
Yep.
So,
actually, those are. This might crack you up. I asked a bunch of people about vacuums, and they're like, "It doesn't matter." I'm like, "I'm going to get one at Harbor Freight." So that's what I bought. I don't know that it's A2L, so I'm going to have to figure that out.
But for the most part, the vacuum, the hoses you connect to the pump and the micron gauge are probably the most important part. As long as your vacuum pump will pull down to around 25 microns.
It says 27 on the box.
Yeah, but for the most part, it just comes down to how much you're going to use it. If you're going to do a dozen installs in your lifetime, that's probably a fine tool for that. But if you're a technician, you rely on your tools for vacuums every day, you're going to have a high duty. Just get something that's you're going to spend a few $100 more, but it's going to last you a lifetime.
Yeah, it's part of the curse of the work that I do is usually I don't do a ton of it. Having Snap-on or Field Piece or something like that doesn't make sense for me. But yeah, if you use your tools every day, get the good tools.
Yeah. When you look at True Blue hoses, you simply can't use a 1/4-inch hose and get the same results. You can't physically get that deep of a vacuum with that hose because it's going to start gas permeating before it can get to that
That's what I was
vacuum
just thinking.
level.
The hose itself is going to leak through the material.
That's what almost every company uses repurposed refrigerant hose. So it's a multi-layer refrigerant hose, and it's actually pinpricked. So those aren't one-way check valves. Those are so the hose can degas. So the carcass of the hose can degas because the hose leaks through. And yeah, so the larger refrigeration hose works better. It's not near as good as a dedicated vacuum engineered hose.
All really that's coming my way. So you're a whole lot of things have pushed me. I've been saying for years, I'm not a technician. I
think there's a handful of people that are out there doing what you're doing, but it's becoming almost a little bit of necessity because the industry's not moving fast enough with equipping most typical technicians with the tools they need, master heat pump installations. If you're going to imagine trying to find a contractor where you're at to do the type of work that you want to do to the grade that you want to get it done.
Bruce is, 72, something like that. And he was fed up with the big company that he'd worked for because they did lots of volume, but mediocre installs, and it just drove him bonkers. So at the game house, I had Tanner Dickerson do a duct design for me. And then Roman Baugh had been busting my chops to try a fit for years. So I went and got a couple of fits and put them on these two houses that are right next to each other. And I gave Bruce the duct design. And at first he was mildly confused, and then he got really interested. And one of the guys that he worked with, who sadly died of cancer last year, like really suddenly, got diagnosed, and 5 weeks later he was gone. But Jimmy did the duct system and he loved it. When I talked to him literally on his deathbed, poor guy, that was one of the highlights of my career, doing that job. And all it was a duct design and a pretty install. There was nothing exotic about it.
It's not that these guys aren't capable.
No, not at all.
I would guarantee you, though, if you asked him, hey, I want to put a system in my house, what do you recommend? 80 plus gas furnace and 2-ton air conditioner, right? Think about it. We have this whole industry that has gotten so grounded in what they do, and they're so happy with the results that they just don't want to change anything or disrupt anything and learn the stuff that it takes to do some of these higher end jobs.
We've all been bit by change. I know I have through the years. I've been an early adopter for years, and there's all this AI stuff. And I know Ben's listening in right now because Ben's been diving into all this, and I'm going all Murtaugh. I'm too old for this crap. Like I don't want to learn it. I just don't. And for all these years, I've learned stuff like GPS in 2004 and satellite radio back then, and cell phone forever, and like all these things. So I get to where you don't want to learn, but I've been bit by some of this stuff too. When something doesn't work and it's really frustrating, it drives you bonkers. Oh. Like the heat pump water heaters right now are burning my butt. All three of the major manufacturers are having significant failures amongst my friends, like 50% plus. My butt's burned and I'm pissed because it's a sealed combustion or sealed refrigeration circuit. This shouldn't be hard. We've been doing this for 100 years. So yeah, I understand as a owner or technician being nervous around the new tech because that is where weird failures end up happening. And if you just go with old tried and true, an 85% furnace, even if you put it against high static, it'll probably be okay. If you install a heat pump wrong, even just a little wrong, they can bite you.
Yeah, I get it. But I also sometimes look at, like finding a brand where you get good support. The guy that worked with at Bosch, Matt Graves, he's been incredible. Just call him if I have a question or whatever. Really haven't any problems I've had to figure out.
Support is critical. That's why I was willing to gamble on the fits, because Roman's, if you need tech help, just call me. I had to call him 2 or 3 times. It was stuff that was, I think it ended up being the manual. I just hadn't found it yet. Yeah, you got to do this, or, oh yeah, set this up this way. Once you get through the learning curve, it's not too bad. If you only use that system occasionally, it's almost not worth the trouble.
All right. We're ready. I'm ready.
I think we're good.
All right.
Now the real Jim comes out. Chops busting is your love language, buddy. I love that. It threw me off for a little while, but I just got used to it. But I have to say, it's been a real pleasure getting to know you over the last, it's been like 8 years. We met in like 2017.
Who are you?
Yeah, that was so funny. I talked about mean radiant temperature and how heat pumps do a good job. Who are you? Like, you said something interesting. I think I actually want to know what your name is, but I was just going to ignore you until then. And what was it? 2020, you got your Bosch. And then I got one the next year. It's been a fun ride because you've got so much expertise in things that I know nothing about. And I always like learning things that are tangential to the other stuff that I do, even though it's strongly related. But as somebody who specifies equipment, I don't really need to know how to install it. I really don't.
And you are so opinionated about things I don't care about.
See?
So,
well, until next time, brother.
All right. Bye.